Okay, good morning, dear. So this is machine learning class again, class number 4. So here we are, right? This syllabus is actually written over there, and we are discussing about data, what data is, and what is intelligent system, autonomous system, and first major portion of our machine learning will deal with statistics. Okay, statistics is a great tool for designing. So I am for designing machine learning models. So I'm calling about model. I'm calling about tools. You know what it means, right? Say I have a tool of consists of screwdriver, this, that. So many things are there in my toolbox, and that I can use for designing several products, right? So those products are actually going back to the digital domain. Those products are machine learning models, and tools are fundamental tools like statistics, connectionist model, all kind of decision tree, right? So we will use them and we'll tell them. Now slowly I am talking about data, and now again we'll show you that you see, this is a data. It is meaningless unless you go ahead and see, and this data, wait, this data has been collected, okay, by very meticulously data collection and making it available to the scientific community. I think in machine learning domain is a very novel job, and people, when you will grow as a professional, also you should contribute to the community by collecting data. Data collection means lots of activities. You need professionals, you need actual activities going on. You see, this doesn't make any sense unless, and you see, the data could be, unless you go to the description, okay. Wait, so now this is the information which you have. Try to study this data, okay. Attributes or features, right? So this is the data for heart disease, okay. First column is actually age. So many things are there. Typical angina, atypical angina. So these are all technical terms, but many terms will be understandable to you also, okay, in hospitals, because you see, one of the giant killer is heart disease. So it is very important to know beforehand whether a person is going to have, whether he or she has heart disease, at what level it is, and if what are the things we can do, knowing the level, so that the life can be saved. So there are so many different features, okay. Admission to hospitals, okay, ventricular hypertrophy. These are actually inside the heart. There are so many vessels, and heart disease occurs when the vessels are blocked or something like that, and that has manifestation in some physical test like different Doppler test, and then treadmill test, and all these things have been, and then you see, these are the tests, and blood test, lipid profile, and then lipid profile. There are compositions of many chemicals which actually gradually block the flow of blood. Okay, so this is anatomical things now, that blood is actually connective tissue, as you all know. It takes energy from the cell and distributes it to the many parts, intricate parts of the organ, including heart. And heart is a pumping machine, right? So as long as heart is healthy, all activities will go on. So this is kind of data which depicts that various parameters, and we will come back here. Now, what I would like to make a point here, some figures here may be missing, okay. Here you can get this in the raw data when you are collecting. Somebody has done some mistake, right? So, data, if you consider is to be a fuel, then fuel has several stages, right? Now, for running a car, you need clean petrol, and how it is produced. Okay, it is produced from crude oil. Okay, crude oil. Crude oil is looking like mud, mud with sloppy things, right? So there are so many process refinery we call. You need to refine those crude oils to give the shape of petrol which can be useful. Similarly, data, if it is a fuel, the data raw data when you collect, because data collection is actually complicated activity, so many people are involved, they are producing their tiny data, tiny job they are doing. COVID data, for example, each country, each lab, they are feeding their country, and those country in turn is feeding to the central agency to make the data available. And sometimes there could be some mistakes, sometimes there are crude entries in the data. So, just like crude oil, to make it in the form of petrol requires so many refinement, data needs processing before putting it to any model. Just like petrol, before putting it to the car, petrol has to have that level of purity. Okay, this is called data pre-processing. Okay, so their crude oil to petrol has refinery who are processing. Here there are so many techniques and tools involved to process the data so that it will be clean when it is entering to the machine or our machine learning model as an input. Okay, so this is called pre-processing of the data. I try to make the concept why pre-processing, always pre-processing is needed. Okay, if you are taking data from different source, okay, or not generating. Many volunteer organizations, universities are there who have created very useful data. They have pre-processed, they have collected data, pre-processed it, means made it clean so that you can use. Okay, so machine learning fundamental requirement is to know statistics, and a large portion of machine learning tools which you will study involves statistics. Okay, so and I believe you have already a course in statistics. Okay, and basically fundamentally statistics is all about collecting data from the environment, which we call sample. Okay, and study the sample behavior and try to predict from sample behavior to the environment or the world, real world, from where you have collected data. Okay, why it is so? Because real world is very, very vast. So we have 130 billion people. If you are collecting data of income of 130 billion people, it will be impossible to do that, right? So what we do? We collect sample from several states of our country. So people and their income, Just give an example. Or people and then their age and their weight, because weight is a great metric for nutrition, right? So you cannot collect all the data, which will be impossible, clumsy, huge, right? So statistics come and save you here. So what we do, we collect sample, and it has to be collected randomly, otherwise it will be biased. Say, in a particular state of India has a very low income group people residing over there, and we have collected sample from there, and particular state may have relatively higher income group people. So we have ignored that, and then we have developed a model based on that sample which is biased. Of course, the model will be biased. It will not be able to predict the environment or the countries as a whole, right? In the macro level, it will not be able to predict. So here is the concept of sample, which you already know. Samples are to be collected randomly, and first what we do after collecting sample, we try to calculate the central tendency of the data to see what is the central tendency of the data by finding the either mean, median, and mode. Those are some parameters, which tells you how the data is centrally oriented. Say simple mean. You have large number of data, you just take an average and replace them by mean. That what does it mean? That means the data will somehow be represented in and around the mean. But wait a minute, just find the board. Wait a minute, you need to know only mean is not enough, right? So you also need to know we call it variance, how the data is dispersed about mean. So if some, and this distribution is called, very common distribution is Gaussian distribution. That means that more, all this actually, the data, if the curve is like this, or another curve say is like this. Okay? The distribution could be different, of a different shape. So what does it mean? Qualitatively, this distribution means the data is very homogeneous. Say, you belongs to 5th semester, right? 5th semester in our system has variation of age, little variation of age, and I have collected data about all 6th semester IIIT students' age and try to plot a distribution, right? So it will be, because it is again micro level data, only say 5th semester, okay? I have ignored entire institute has say 2000 students, 5th semester has 200 only. I have collected data about that group and I have made a distribution plot. So I will maybe I will get this kind of distribution. Now if I try to take the, okay, now not in micro level, I will try to predict all undergraduate students' age, okay, how it varies. So it will be a little bit more heterogeneous. Now it consists of our undergraduate is 8th semester, right? So first semester student age group is different, second semester is a little bit older, third semester is further older, like that. Okay, so if I now try to collect sample and try to figure out a distribution, my samples will be dispersed, right, with respect to this mean more widely, right? So these are the things you already know. And suppose now I see, okay, what is the distribution of age of the entire IIIT family, which consists of undergraduate, postgraduate, PhD student, teacher, all staff, then definitely it will be further flattened like this. So this is all you know. And if the data is, this distribution is called Gaussian distribution or normal distribution. So basically it is trying to tell you, if you have collected sample and then you see how the sample is distributed, and it's very important to know, for me to know that distribution, because now from that sampled and from that model I will try to predict that, okay, throughout our entire country, all the 5th semester students, the age will be distributed like this. Okay, so this is the very simple idea what statistics can do. Statistics actually try to collect sample and analyze the sample, and it tries to predict the entire environment from which the sample was collected. That's why randomness is extremely important. Otherwise, your model will be faulty. Okay, it will be biased. Okay, and also I told you that there are 4 kinds of learning. One is supervised learning. Unsupervised learning. Then reinforcement learning. Another kind of learning is called transfer learning. We'll try to understand all these learning techniques. So if you have data, then I try to classify, I try to make a model which will understand the data's knowledge hidden over there, and I try to create a model for that, okay, using, say, technique of supervised learning. Incidentally, this is the most commonly used in the industry. I should say more than 90% learning strategy is supervised. Okay, some learning strategy is unsupervised. Reinforcement learning, transfer learning is not working well, but it's a beautiful concept. But reinforcement learning is actually working, and people are doing research. So let us try to understand the basic 4 different learning strategies. Supervised learning is what? Say, I had housing pricing data. I will have to have a level data. Okay. Say, this much floor area, price is this. Let us assume only one feature, floor area. This much of floor area, price is this. So floor area tagged with the price. Floor area tagged with the price. And with that, we are trying to create a model. Or maybe for unstructured data, cat, image of a cat, I am telling that, okay, image of a cat means this is cat is represented by class 1, okay, and all other non-cat are 0. Or dog, okay, this is the image of a dog. It has to be labeled, okay, that cat, dog. If you want to design a model, machine learning based model, which will actually, after learning, okay, which will actually classify, when the learning is over, you give a picture of a cat, randomly picture of a dog, it will tell you, it will output you 1 or 0. Okay, this is called binary classification. That is a concept of softmax matrix also, which can multiple classifications also can be done, which we discuss later on. But binary classification technique is very common. Supervised learning is very common, and this supervised learning is in our human way of learning. We use it very much. I will try to draw an analogy. Say, when a kid is first learning from parents, mother, right? This is this, this is that. Say, first learning of language. Okay, in any language, the kid is told this is A, this is B, this is what, right? And this is that. Not only in language, everything in initial stage of learning, somebody, either it is teacher or parents, supervise in telling its brain, the kid's brain, which is a gigantic model, it's telling you that this is this. And from there, the kids try to pick up when there is no teacher, and some of the already taught alphabets or things have been inputted, he or she is seeing, and they will be able to tell what it is. And the way, the mechanism, what is enabling them to tell what it is called a learning model based on supervised learning. Okay, similarly, unsupervised learning. When the kid is growing, it is seeing many different things. Some of them has been already taught specifically with some level, analogous to level, specifically by teacher or parent. Some of them may not be have level in their context, right? First time the kid is seeing something, but based on it's not level data anymore for him, right? For him or her. So in an unsupervised way, he is trying to learn when many such things they are saying, which is not leveled, and trying to evolve some learning that, okay, if some similar pattern is seen, it should be like this. Okay. More we will discuss about this. Unsupervised learning technique is more non-intuitive, and we will talk about that there are so many different ways of unsupervised learning. So in the next class we will do, and then we'll give you a fun assignment in the next class. Okay. Stay safe. Have a nice day. Bye bye.